Here we go, full screen. Hey, so I just want to thank everybody for trying out this Flip the Classroom year. This is the last video I think that I need to take for the year. This is the last section of Chapter 12, the last chapter that we do. I'm not sure if that's the case. We're still trying to figure out what to do with statistics unit. I might take a video there, but maybe we'll just do it in the classroom. Anyways, thank you so much for doing this. I know a lot of you have loyal, really, it's helped you. You've told me, and I appreciate that. Certainly going to put a survey out at the end of the year and try to get some more feedback from you. I've enjoyed taking the videos, and I really like how much work we do in class, which is great. So here we go. This is this section is called Use Recursive Rules with Sequence and Functions. And so we have some vocab. Explicit rule is a rule for a sequence that gives the nth term, a sub n, as a function of the term's previous number. So you can't, an explicit rule, you can't jump ahead and say, oh, let's figure out the 50th term without knowing the 49th and the 48th and the 47th and so on. A recursive rule is a rule for a sequence that gives the beginning term or terms of a sequence and then a recursive equation that tells how the nth term is related to one or more previous terms. So you could have a recursive, where you're looking at the last two terms, add the last two terms, subtract the last two terms, or something else. And then iteration is a repeated composition of a function. So you basically take the answer and keep plugging it into this function, a linear function, for instance. Here's our first example. So here's the rule. It looks a little different than what you've dealt with in the past with this n minus 1. But this n minus 1 means the previous term. So if I want to figure out the first term, I need to plug in, I need to take the n minus 1, or 1 minus 1, which is 0, and subtract 3. So let's do one go at this, right? So the first term would be the previous term minus 3, right? And you have to be given this initial value, which they do here. So when you write these rules, you have to include that first piece, which, it's easy to forget, especially with the other sections in the book. How would I figure out the a sub 2 term? I would take negative 1 and subtract 3. And then I'd take the next term would be negative 4, right? The answer, the previous term, minus 3. And then you keep going. So again, you keep taking that previous term and subtracting 3. So negative 4 minus 3, negative 7 minus 3, negative 10. And you could see this kind of recursive, this reoccurring rule. Pretty fun, really a neat exercise, and limiting. You can't just jump ahead from the first term to the fifth without figuring all the terms in between. Why don't you go ahead and try one just to get the feel for it? They would like you to write the first 5 terms. Realize the first term is already given, right? First term is 4. So now you would take that term and multiply by 1.5. Then multiply by 1.5. And you should quickly see that you'll go to 4, 6, 9, 13.5. And you just keep multiplying by 1.5, 1.5. It's fun. Unfortunately, you can't look ahead and see what the 10th term is without building up to that point. So if you know that you've got an arithmetic sequence, the recursive rule is to provide, take the previous term and add the difference. And again, you'd have to start with some, term. You'd have to give that in the rule. Geometric sequence, we take the previous term and multiply by the ratio, r, the common ratio. So here we've got 2 rules, and we'd like you to come up, 2 sequences, and we need you to write a recursive rule. So again, this vocab is important that, like on a quiz, you'd say, oh, you want the recursive rule, different than the rules we were doing previous. So the first sequence, hopefully you recognize this, we are adding a constant, and this guy looks like we're multiplying by a constant. So the first one, it is indeed arithmetic. The difference is 6. So when we write the rule, we'd say take the previous term, and again, n minus 1 means the previous term, add 6. And you have to provide, I don't like the book that they split this up. The rule has to be written together, like this, circled. I have a hard time moving my pen. Yes, I got it. There we go. So that is the rule. A sub 1 is 1. And again, if you leave out that a sub 1, like if that's not part of your answer, you can't work a rule that doesn't give the previous term, doesn't give that starting term. The second sequence is geometric. The ratio looks like quite clearly you're multiplying by 3. So you would write the rule, get rid of this, would be, again, you'd have to include the first term, and then, oops, almost had it. There we go, right? So you'd have to provide the first term and then say, okay, start this process. Plug 4 in, 4 times 3 is 12, plug 12 in, 12 times 3 is 36, and so on. So here we get into the special sequences, and they're tricky. They are tricky. So check out the number pattern. 3, then goes to 5, then to 2. So you go up, then down. We've never seen one like this before, and then it continues to go down. I'm just going to give it away because I think these are really hard to come up with. But basically what you're doing is you're taking 5 minus 3 to get the next term. Then you're taking 2 minus 5 to get the next term. And you're taking negative 3 minus 2 to get the next term. And so the rule, basically, to write that, you say, hey, take the previous term, n minus 1, and subtract the previous term 2 terms ago. I don't know how to say that. The 2 previous term, the second previous term, the previous term squared. No, just kidding. And so here's the rule, and you have to then also give the first terms to get you going, right? So this rule, I should have drawn this together, but this rule needs 2 terms to get you going. So pretty tricky, pretty special sequences. So here, why don't you try these, right? If you hit pause, I think you've got an arithmetic, a geometric, and a special. Special would be nice, right? Put a star next to special. If you can get that one on your own, that's really awesome. Hit pause when you're ready, hit play. And there you have the answer. So first one was geometric. Hopefully you recognize you're multiplying by 9. So you'd provide the first term, and notice they did a sub 1. They're allowed to. You're allowed to. You could have written a sub 10. I don't know. It's kind of weird, but as long as you give some starting point, you can figure out the next term. This one is arithmetic. Looks like you're subtracting by 11, and so the rule would be take the previous term minus 11, and then state the first term. And then this guy, I don't know if you figured it out, but you take the previous 2 terms and add them. So again, the order in which you write this doesn't matter. This could have been n minus 1 plus n minus 2. But you take the previous 2 terms, add them up. So in your rule, notice you have to provide the previous 2 terms to get you going. Nice. So the last bit of this section is called iteration, or iterate a function. And so you're given the function. Notice the function, nice line, linear function 2x minus 5. And then they give you an initial value. They call it x sub 0. For initial of 3, and you would take 3, plug it into the function. Oh, well, they did it. Yeah, so just focus here for a sec. They plug 3 into the function. 2 times 3 is 6, minus 5 is 1. And then how do we go to the next one? We plug 1 back into the function. 2 times 1 is 2, minus 5 is negative 3. Then we take negative 3 and plug it into the function. 2 times negative 3 is negative 6. Negative 6 minus 5 is negative 11. And you just keep going round and round, right? You just composition. You just keep plugging the answer back in, back in. Composition meaning, this could also have been written f of 3. Oops, that's supposed to be parentheses, right? So plug 3 into the function, take your answer, plug it back into the function, take your answer. Plug it back into the function, take your answer. But it's nice because you get to see the different answers along the way. I love it. I think iterating is so fun. Give this one a go. Parabola, right? First term is negative 2, so take negative 2, plug it in, right? Square negative 2, add 3, get an answer. Take that answer, square it, add 3, take that answer, square, and so on, and so on, and so on, and so on. And you should get these numbers, right? 7, 4, negative 2 squared is 4. 4 plus 3 is 7. Take 7, plug it in, you get 49. 49 plus 3 is 52. Take 52, square it, you get 2,704. Add 3, and you just keep going. Be careful with this because it did ask for the first 3 iterations, and we don't list negative 2 because we didn't do anything, right? That's not an iteration. When you iterate, you've actually processed a number, and you'll get 7. Hey, well done. Again, for those of you that have been watching the videos all year, I really appreciate it, your effort, and a lot of you have said it has been super helpful. So I'm hoping that that helps you a lot.